Hello and welcome to my science tutorials. In today's video, we are going to be talking about laboratory equipment and their uses. Before we begin, if you are new to my science tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. Now, whether you are in college or you are in the university or you are in a high school, you need to know the equipment to carry out experiments in the laboratory. Now, the equipment may differ depending on the laboratory that you visit. For instance, a chemistry laboratory may have equipment that you may not see in a biology laboratory. The same way for physics laboratory. So, the equipment may differ depending on a particular laboratory that you visit. But in today's tutorial, we want to talk about the most common ones and their uses. Now, mostly when you enter a laboratory, before you carry out an experiment, you are given an instruction manual with laboratory equipment and their uses on the front page or at the back of the manual. Now, sometimes it is difficult for students to identify these equipment if they've not seen or handled them before. Hence, for the sake of those students, we want to use realistic 3D models of these equipment so that the students can easily identify them once they see them. So we will not be using just line drawings or flat drawings for this tutorial. We'll be using 3D models of the equipment so that students can identify them once they see them. Alright, so without further ado, I present to you the top common laboratory equipment and their uses. Alright, so the first one we want to look at is the tripod stand. Now, the tripod stand is used for holding flasks or pieces of glassware in place when heating or warming. So we can see that the top over here, where my pointer is circling around, that is where we put the glasswares, okay, so that we can use the Bunsen burner as the source of heat and warm our solution contained in the glassware. Now, the second one is the Bunsen burner. Now, the Bunsen burner serves as a source of heat. So you want to warm a reaction so that it will proceed faster, or you want to warm something in the laboratory, you need to use the Bunsen burner as your source of heat. Next, we have the weighing or the chemical balance. Now, the chemical balance or the balances are used to determine the mass of a reagent or an object or a sample. So, for instance, you want to weigh a specific gram of maybe calcium carbonate in the laboratory, you use the balance. Maybe you want to determine the mass of the reagent that you need to use to prepare a standard solution, you need to weigh it in the laboratory. So, anything that you have to weigh in the laboratory, you use the balance or the chemical balance for your measurement or your weighing. Now, the fume hood or the fume chamber. Now, the fume hood serves as a ventilate for noxious gases or harmful gases. Okay, so when you are carrying out an experiment that involves the evolution or the effervescence of gases, you need to make sure these reactions are carried out in the fume chamber. Now, if you don't carry them out in the fume chamber, these gases, as they come out, they diffuse into the air and you are inhaling them. So that will pose a problem in the future. For security reasons, you carry these reactions to the fume chamber. You add maybe reagent A to reagent B. The gas is evolving. You leave it in the fume hood so that the gases, as they come out, the fume chamber will channel it outside so that you don't have direct contact with the gases and you inhale them. Now, the next one I want to talk about is burette. Now, burettes are for addition of precise volumes of liquid. So, for instance, you are doing a titration and you need to deliver a certain amount of volume of maybe a base to an acid, or in drops, you use the burettes. So, mostly maybe you need 2 drops or 3 drops or 4 drops for you to reach the endpoint during the titration. You use a burette so that the knot over here, where we have the knot over here, allows you to close and open your burette to deliver a specific amount or smaller volumes of liquid to your reaction. Now we have the test tube rack. Now the test tube rack, they are used for holding test tubes filled with chemicals or for drying after washing. So we can see that over here, we can see that the test tubes are being held by the test tube rack, or if you wash them with water and you want it to dry and the liquid or the water to drain, you can put them on this wood structures that we have over here, so that you can easily dry them and it will be turned upside down for the liquids to come out. So that is the use of the test tube rack, for holding test tubes or for drying after washing. That is for drying the test tubes after washing. Now we have the test tube holder. Now the test tube holder or the test tube holders are for holding test tubes when the tubes are not supposed to be touched directly. So for instance, maybe you want to warm this test tube with the reagent or the chemicals inside. Now if you are going to use the Bunsen burner to heat this, you don't want to hold the glassware whilst you heat, because the glassware will become hot and you may leave it when the heat is transferred to your hand, and then you may leave it and you may break the glassware. So to prevent that, we use the test tube holder to hold your test tube before you apply your source of heat to warm your reaction. Next are the droppers. So the droppers are for adding what? Liquids drop by drop. So mostly we use this to add indicators to reactions or reagents. So for instance, you want to do an acid-base titration and you need to add phenolphthalein to a base before you deliver your acid from your burette. You need to use the dropper to pick up your phenolphthalein or your metal orange, and you just deliver them drop by drop to your acid or to your base. So droppers are for addition of liquids drop by drop or in smaller quantities. So next we want to talk about beakers. Now beakers are very useful reaction containers, so we can carry out reactions in beakers or to hold liquid or solid samples. So they are also used to cut liquids from titration and filtrates when filtering or during filtering operations. So beakers have a lot of uses. We can use them as containers, just pour water or reactions or reagents in them. We can carry out reactions in them. Maybe we add an acid, we add a base to it to see what will happen. That is on bigger volumes of reactions, and they can also be used to catch liquids from titration and filtrates from filtering operations. Now we have the Erlenmeyer flask or the conical flask. So the flask is useful to contain reactions and hold liquid samples. They are also useful to catch filtrates. So just like the beakers, the Erlenmeyer flask also have the same uses, but mostly we use the Erlenmeyer flask during titration. So if you are adding your acid from the burette to your base which you have in your conical flask, you need to make sure you use the conical flask because the beaker has a bigger mouth. Okay, so when you're adding in, you need to be shaking. So if you are using a beaker, the shaking becomes difficult, but with the conical flask you can easily shake, okay, so that your acid and base will mix each other and then you can get your endpoint faster. Right, so we have the suction or the filter flask. So this flask can be used as a vacuum trap to ensure no liquid or fluids are carried from the vacuum pump to the evacuator apparatus or the vice versa. So when you are filtering and you want to filter by vacuum, so we connect the vacuum pump to this side using a tube, and then we place your funnel with your filtrate and everything here. So as the liquid drops over here, the vacuum pump is sucking the air out of the container or the flask, thereby making the water or your solution that has the solid or your filtrate and the solution, your vacuum will be sucking the air out of it, and then the water will be forced to come out at a faster rate. So the water will be prevented from going to the vacuum, and the same way from the vacuum source into your flask. Next, we want to talk about graduated cylinders. Now the graduated cylinders are for measurement of an amount of a liquid. So for instance, we can see the smaller one that we have over here, if you want to measure a smaller amount of volumes of liquid or smaller volumes of liquid, and we want a precise volume, maybe 0.5, 0.6, 0.7, we use the smaller measuring cylinders because the graduations can favor those measurements. But we use the bigger ones if we have to measure volumes like 50 ml, 20 ml, 25 ml, because the smaller ones may not be able to measure those 50 ml because they are not large enough, but the bigger ones can measure. So depending on the specific amount or the volume of liquid that you need, you may use the measuring cylinders or the graduating cylinders to do your measurement. Next are the sample tubes. So like the name suggests, they are for holding or collecting samples, either solid or liquid. Sometimes when you go to the clinic or the hospital and they want your excreta, sometimes they ask you to go and then put your excreta or your waste into the sample tubes and bring to the lab for analysis. So the same way in the chemistry or the biology or the physics laboratory, for samples to be collected, smaller samples, we use the sample tubes for that purpose. Now I'm going to be talking about the clamps and then the rectal stand at once. Okay, so the clamps, they are used to hold burettes during titration or other pieces of equipment in place when carrying out experiments. So we can see that we have the clamps, these two are the clamps. With this one, okay, so we have 3 clamps over here, so they are used to hold this piece of glassware, and then the same as this piece of glassware over here in place during this experiment. So you can see that the clamps are used for holding. Now the supporting ring over here, okay, are for holding pieces of glassware in place. Now they support a beaker over a Bunsen burner. Wire gauze are usually placed on this structure. So we can see for this setup, we can see that the ring provide extra stability to this flask over here. Assuming we don't have the ring over here, the likelihood that this clamp will just hold this flask in place until the end of the experiment is very low. So maybe an acid or a base or something may be around the neck of the bottle, and then that may cause the bottles to slip or the flask to slip. So with the supporting ring, it provides extra stability to make sure that the flask does not fall from the clamp. Also, we put wire gauze on it, and we put support direct application of heat when we want to apply or we want to warm our solution. So the rings are for extra stability and are for supporting beakers and Bunsen burners. Now the rectal stand, like I said, they also support the burner iron ring, pipe stem, triangle, and other items whilst heating a substance. So you can see that the rectal stand over here, they are supporting the clamp, okay, the clamp and then the ring, as well as they are giving extra stability to the clamp and then the ring over here for them to be able to also function. So the clamps and then the rings cannot function without the stand, and then the stand alone can also not hold pieces of glassware together. So they all work hand in hand. Now the next thing we want to look at is the pipette. So pipettes are used to dispense small quantities of liquid. So just like the burette, pipettes can also be used to dispense small amounts of liquids. So for instance, you want to take maybe 25 ml of sodium hydroxide into a conical flask. Use the 25 ml pipette to deliver the precise amount of liquid into your flask. Okay, so those are the uses of pipette. Now we have the stirring rod. So if you have a solution, maybe a solid and a solvent, and you want to quicken the rate of dissolution, you use the stirring rod to stir so that your solutes can dissolve faster in your solvent. Also, if you are warming a solution and you want to distribute the heat evenly as the reaction proceeds, you need to make sure you use the stirring rod to stir so that you distribute the heat evenly as the reaction proceeds. Now, test tubes, like I said earlier on, test tubes are for holding small samples or for containing small scale reactions. So if you want to carry out very small reactions, you don't need to use beakers or flask. You can just use test tubes to test for those reactions. For instance, if you want to test for certain cations, maybe iron 3, iron 2, copper, you just make sure you put your reaction containing the copper ions, and then you add the specific reagent needed to test for that particular ion. The formation of certain characteristic pipetties show or indicate a certain type of ions that are present in the wet chemical test. Now, funnel, they are used for transferring liquid from one container to the other, or for filtering when equipped with filter paper. So if you want to transfer liquid from maybe a volumetric flask into a conical flask, we can use we don't want to do it directly, we can use the funnel as a medium to ease the transfer of liquid from one container to the other. Now we have the volumetric flask. Now this flask are used to prepare standard solutions, that's solutions with known concentration. For instance, we can see that the label over here is 250 ml. So assuming we want to prepare 250 ml of calcium carbonate solution, all we need to do is to weigh a specific amount of our calcium carbonate solid, and then we dissolve it in a small amount of water and we transfer it into the flask using the funnel. Now after we transfer, we use the wash bottle to add water to the flask. Now the mark on the neck over here, we need to make sure we add the water to the mark to the extent that the meniscus of the water is exactly on the mark. Okay, so in that case we've prepared our standard solution. So we can now stop it, or we can use a stopper to stop it, and then we shake the reaction slowly or gently to form or for uniform distribution of the calcium carbonate dissolved in water in our standard solution. Now we've already talked about the flask and then the suction flask, so we are going to jump from there. So the next one we want to look at is the round bottom flask or the boiling flask. So these are for holding solutions or reactions during heating or warming. So like we saw when we had the Ritter stand, they are used to contain reactions during warming or heating. Now we also talk about the measuring cylinders and then the beakers already. So let's just talk about the glassware that we have over here, which is the measuring or the graduated cup. So they are used for transferring measured volumes of liquids. So assuming you want to transfer maybe 500 ml of water, and you can see that this measuring cylinder is only 100 ml, and you don't want to go around measuring with the measuring cylinder 5 times, you can use the cup and then you add your solution to the 500 mark over here, then you transfer into your container that you want to transfer your liquid. So it is the measurement of liquid instead of using measuring cylinders to do that repeatedly. Alright, so we have next on our list is the crucible. They are containers made to resist heat. So they are container in which metals or other substances may be melted or subjected to what? High temperatures. So they are resistant to high temperatures, and therefore if you want to melt something, you can put it in the crucible and then you apply heat to it to melt the substance. Now we have the mortar and the pestle. So if you want to grind any substance in the chemical laboratory or in the lab, use the mortar and the pestle to grind the solid or the substance into a powdered form. Next, we have the evaporating dish. Now, the evaporating dish is used to evaporate excess solvents to create more concentrated solution. So if you have a solution and you want to evaporate it, you use the evaporating dish, like the name suggests. Next, we have the watch glass. So the watch glasses are for holding small samples or for carrying beakers or evaporating dish. So we can use them as covers for beakers and evaporating dish during reactions, or they are also used to hold small samples in the laboratory. Now we have the petri dish. The petri dish and cover are used in laboratories to culture different microorganisms and soil. So most biologists and microbiologists normally use the petri dish a lot for the cultivation of unicellular organisms or microorganisms and cells. So that brings us to the end of some basic or common laboratory equipment and their uses. So thank you so much for watching, and thank you for staying till the end of the tutorial. If you are yet to subscribe, kindly make sure you subscribe to the channel, as we post daily videos on anything that concerns science. So thank you once again for watching, and I'll see you in the next video. Bye bye.